The final lesson in the analytic geometry unit is for the equation of a circle. So the circles we're looking at in grade 10 academic math are the circles that are centered on the origin. We're not going to move it left, right, up, or down. We're going to keep it centered on the point 0, 0. So the equation of a circle with a center at the origin that has a radius r is given by the equation x squared plus y squared equals r squared. So this is probably the easiest topic of the unit. All you have to do is take the radius, you square it, and it goes at the end of the equal sign, and that's the equation. So for example, if the radius was 8, as in example 1a, the equation would be x squared plus y squared equals 8 squared. And then you simplify the 8 squared. Remember that 8 squared means 8 times 8, not times 2, right? So it's 64 instead. So that would be your equation. That's the whole answer for question 1a. Looking at question b, it's got a square root in the radius. So if the radius is the square root of 13, and you want to square that, the square root and the square just cancel each other out. So it's equal to what's underneath the square root sign to begin with, the 13. So the answer here would be x squared plus y squared equals 13. So same thing for c, x squared plus y squared equals 3.5 squared, and you can find out what that is, and that would be the answer for your equation. Let's take a look at some questions that are a little bit more difficult. If you were trying to find a point on the circle, so for example number 2, it says for each question state the radius of the corresponding circle and give the coordinates of one point on the circle. So all you have to do for that one is you have to go backwards. So if you're trying to find the radius and you know that this last number here is r squared, you're going to square root it. So if radius squared is 16, then the radius would be the square root of 16, which means it would be equal to 4. So the square root of 40 in the next question would give you your radius r squared equals 40. So the r would be the square root of 40, which should be 6.9 units. So in those questions, it asks you to give the coordinates of one point on the circle. When you find the radius, it kind of shows you what the graph looks like, because you can picture a circle centered on 0, 0. Don't mind my circle skills. And every corner or every side of the circle where it touches the edge of the axis, this distance right here is the radius. So if the radius was 4, the coordinates of this point right here would be 4, 0. And then on the negative side, it would be negative 4, 0. At the top, it would be 0, 4, and 0, negative 4. So just keep that in mind. You can find as many points as you want in the circle because you know already what the radius is, and you can use that radius to figure out the x and the y intercepts. So let's look at example 3 on the next. Determining whether a point lies on, inside, or outside a circle. Now this should sound a little familiar. Whether a point lies on something, on a line for example. We've talked about that many times so far this year. If you're going to determine or prove or verify or check if a point lies on anywhere, on anything at all, the way that you're going to do that is by doing a left side, right side check. So anytime you see this, think left side, right side. Oops. So in this question, they want to know if it lies on, inside, or outside a circle. So we'll talk about inside and outside in a moment. Determine an equation and the radius for the circle that has its center at the origin and passes through the point 6, negative 8. So first let's find the equation. We're going to substitute the 6 in for the x, the negative 8 in for the y, and we're going to solve for the missing r squared in our equation. So x squared plus y squared equals r squared. The x is 6, the y is negative 8. So 36 plus 64 is equal to r squared. Don't forget, this will never ever be negative. If you square a number, regardless of its sign, it equals a positive answer. So r squared is 100. You don't even need to know r because that's what goes in the equation. So the equation of this circle is x squared plus y squared equals 100. That's our final answer for the equation. So that was part A, determining the equation of the circle. Part B asks you if the point B, which is negative 5, 9, lies on, inside, or outside the circle. So we're going to do that left side, right side check that we talked about. So we're going to make our left side, right side chart. We're going to put our equation in there. So we have 100 and x squared plus y squared on the left. And we're going to substitute in our values. So the x is negative 5 and the y is 9. So negative 5 squared make sure the negative 5 is in brackets because it's the whole x squared, plus 9 squared is 25 plus 81, which is 106. Now the right side is equal to 100, so those are not equal. Since the left side is not equal to the right side, we know that that point does not lie on the circle. On would be if the left side and right side were equal. Now the left side in this case is greater than the right side. This means bigger. So that means that the point B lies outside the circle. If our left side were smaller than the right side, that would indicate that the point lies inside the circle. So outside is if it's greater than, inside is if it's less than. Example 4 looks at the last piece of vocabulary you need to know for circles, and it's the chord. A chord is a line segment that joins 2 points on a curve. So it doesn't need to be necessarily a circle, but any curve. So we can have a chord, later on we'll look at parabolas, we can have a chord and a parabola as well. So if you join 2 points on a curve, it's called a chord. We're looking to find the equation for the right bisector of the chord. So we have a chord, it's right here. We're trying to find the equation for the line that goes through the midpoint of the chord at a right angle. So to find an equation of anything, the 2 things we need are slope and a point. Slope and a point. So if we're looking at the right bisector, this line right here, we're going to use the slope that is perpendicular to the chord, perpendicular to the slope of the chord, and we're going to find the point that's in the middle, the midpoint of AB. And we're going to use those 2 things in our equation. So our slope of AB is negative 4 minus 2 over 2 minus 4. I'm getting those numbers right from the graph, point B and point A. So negative 6 over negative 2, which is 3. That's the slope of AB. So the perpendicular slope then would be equal to negative 1/3. That's the slope we'd be using in our equation for the chord. Finally, the midpoint, I'm going to have to make some space down here. The midpoint is calculated by averaging the 2 coordinates. So the midpoint in terms of its coordinates are the x's added together and divided by 2, and the y's added together and divided by 2. So 6 over 2 and negative 2 over 2, which reduces to 3, negative 1. Does it look like it's 3, negative 1 on the picture? Yeah, it does. It goes over 3 and then down 1. So that makes sense that it would be that. Also, our perpendicular slope looks like it goes down 1 over 3. So those 2 details of the equation definitely make sense. So finally, we're going to include those 2 in our equation. So y equals m bracket x minus p plus q. I'm using the point and the slope that I figured out in my equation. So I'm going to distribute that into the brackets. So y equals negative 1/3 x plus 3 over 3 minus 1, and 3 divided by 3 is just 1. So negative 1/3 x plus 1 minus 1 equals negative 1/3 x. The y-intercept of this equation would be 0. Now looking at the picture, does it go through 0, 0? Yeah, it absolutely does. Verify part B that the right bisector passes through the center of the circle. So does it pass through 0, 0? The way that you verify anything with an equation is by doing a left side, right side check. And we figured out the equation already. It's y equals negative 1/3 x. So we're going to put 0, 0 in there and see if the left side and the right side are equal. So the left side would just be 0, and the right side would be negative 1/3 times 0, which is also equal to 0. Since the left side equals the right side, therefore, the perpendicular bisector of the chord passes through 0, 0, or the origin. And that's actually a property of a right bisector, it always is going to pass through 0, 0. Because the circle centers around 0, 0, any right bisector of any chord on the circle will pass through the origin. So that is the end of the review, and the following pages in your workbook are just to help you prepare for the unit test, which is at the end of this week. I wanted to post this last lesson to give you adequate time for review. Definitely spend some time going over median, altitude, right bisector. We will spend the next couple of days in class talking about the things that we've studied and looking at questions together and going over the topics that you'll need to know for your unit test. Feel free to send some emails or to leave a message on the posting board if you have any questions. Have a good night.